So the final part of Unit D is applying this stuff to problems. And so these are going to be word problems, and I'm going to divide them into three different kinds. We're going to have some that are in this first video on that are ready-made. And so you're given the equation, and then you simply have to solve the equation. The next thing you're going to do are geometry problems. So that will be in a separate video. And I think I've given about four different kinds or four different examples in the notes. And the third kind are number puzzles. So I made them into individual little videos just so you could kind of subdivide them in your mind a little bit. Yeah, and I've given a limited number of them in the homework and assignments that and sometimes offer choice on the exam. So here's our first one. This is a ready-made equation. A lot of these are going to be projectile type problems or maybe business models that you can use to analyze the problem. So suppose a person throws a ball straight up in the air, releasing the ball at a height of 5 feet above the ground. So this is about a 5-foot tall person, and they're going to throw the ball up. They're going to throw the ball up with an initial velocity of 80 feet per second. Eventually, we know it's going to come down. So according to this question, this motion is governed by this equation. So the height of the ball is equal to all of this as a function. So it says, when is the ball at a height of 69 feet? So we know that here it's at 5 feet, right? We want to know when it's up here at 69 feet. So it's going to be down here is on the time, and up here would be on the age. So this is a bit of a sketch trying to, if I was in person, I would be acting this out for you right now. If we want to draw a picture of this on a graph, it would look something like this as a parabola, right? So time is down here, it's on the X, and height is up here on the Y. Height is in feet in this question and time is in seconds. So this question says we want to know when it's at 69 feet. So ideally what we're going to be solving for are the times when it's 69 feet from the ground. So here we have the equation that we were given, subbing the 69 in to the height. So in this one, we are given that as our equation. We're given the piece of information of 69, and now it says solve for t. So we need to make this into quadratic form. We have to set this equal to 0. And so I would subtract 69 from both sides, and I would get that 0 equals negative 16t squared plus 80t minus 64. So with this in mind, we can always use the quadratic equation. So A would be negative 16, B would be 80, and C would be negative 64. So what I'm going to do is start with my quadratic equation and sub these values in. You'll remember that with the quadratic equation, there were the two options. If you need to refer to what the quadratic equation is, then go ahead and pull out that formula sheet. But I would have x equaling negative b plus or minus square root of b squared minus 4ac all over 2a. Now, all of this can be done on your calculator. I think in the other time that we did the quadratic equation, I said, let's make this make a little more sense, and let's just start by evaluating what's over here. And so you can do that part on your calculator. It does not work out to be a nice, neat number. I'm going to rewrite where I got to, plus or minus, everything underneath that radical sign, I got 2304, and that's all going to be divided by 32. So now we're in a good place where it's made a little more sense. We can do the two options, remembering that we have the positive and the negative option on that radical sign, on that square root sign. So we have the positive option that x equals negative 80 plus the square root of 2304. And if you've put that in your calculator, you realize it doesn't work out very easily at all. And so on your calculator with this one, oh, it does work out easily, sorry. We get x equals negative 80 plus 48 all over negative 32. And x would then equal negative 32 over negative 32. Or x equals 1. Or the other side, the negative option, and I'm going to skip that step now that I remember that this works out evenly. So minus 48 all over 32 gives me x equaling negative 128 over negative 32, or that x equals 4. So these are the two times, or I should have actually put a t here, right? All of these, I did make this mistake before. Time is equal to, all of these, my answer key actually has an x there. It really doesn't matter. We know that time is on the x-axis, but these are the times when the ball is at 69 feet. So at 1 second and at 4 seconds, the ball is 69 feet in the air. So after you're done that, you should check that it does make sense, and that seems about right. If you throw a ball up in the air, it takes a while to come back down. So state the answer to the problem. I've put that in the box. See above. And as a bonus here, try subbing 0 in for t. And so what I want to figure out is h equals, f of 0 equals 0, or sorry, my goodness. I scrolled too far. Negative 16 times 0 squared plus 80 times 0 plus 5. So all of this goes away. And the bonus is, what does this mean? So what this means is that at time 0, the ball is 5 feet from the ground. If we go back to the pictures that I drew, that's what I was saying right here, right? So the ball starts at 5 feet off the ground at time 0. And so really what we're talking about in all of these is having a system of understanding a real life event through the use of the quadratic equation and quadratic formulas. Okay, so what this actually means, I should put this in words here. At time 0, the ball is 5 feet off the ground. Or that's the height of the person that was throwing it, right? Like that's where the ball started. Okay, let's try another one of these. So these are all ready-made equations. So imagine you're on a diving platform 5 meters above the ground. You launch yourself up with a velocity of 1 meter per second. How long will it take you to hit the water? And we want to round to 1 decimal place. So this is a case of using the quadratic where it doesn't work out super nice and neat. So the formula used is given to us. Remember, these are given equations. We're interested in how long it takes for the h to become 0. So we want to know how long it will take you to hit the water. If I drew a little diagram of what's going on, put a space for me to draw that there. You're going to jump up and then down into the water. And so we know that this is at 5 meters. And so what we want to do is figure out this time right here. So h is height and t is time. So height and time. So this gives us this equation that we can then use the quadratic for. Because when you hit the water, you're going to be at height 0, right? So A is negative 4.9, B is 1, and C is 5. So what I'm solving for is T. I did not write an X this time, even though there's an X all over my notes. So negative B plus or minus B squared minus 4AC all over 2a. So all of that's correct. If I do just what's underneath the square root sign, whoops, sorry, thought I was deleting, I get a plus or minus or a square root of 99. So this is not a nice even number. We're going to have the two options. We're going to have the positive and the negative. So time would equal -1 plus the square root of 99 divided by -9.8, or time would equal -1 minus the square root of 99 all over -9.8. Take your time with your calculator on this one. Not being able to punch in a nice neat number there makes it hard. I get that time equals -0.9 or time equals 1.1. So that's the calculator work. In real world, as we're dealing with time, we can ignore the negative answer. You can't go back in time, so it can't be a negative number. And so we can see that it took about 1.1 seconds to hit the water, right? This is in seconds, as time was, and that's when our height was 0. This is also a bonus. We can use all the other things that we've learned with quadratics in this. So we can also use the vertex formula to figure out how high above the platform we jumped. So we know that there's going to be an ordered pair for our vertex. And we know that we can solve for the x, or the t in this case, with -b over 2a. So time would equal -b over 2a. So the time would equal 0.102041 seconds. I did that on my calculator. So we're hitting the highest part of the arc after about 0.1 seconds. That height corresponds to the x of our vertex. And so this would be 0.1. And if we sub that time in for into our H formula, we could solve for the y. If I do that, I get f at 0.1, and subbing all that in, I wish this was a nicer set of numbers, I get on my calculator 5.1. And so what that's saying is that you are jumping a whopping 10 centimeters before you start diving down into the water. And so this is the vertex. So for all of these questions, we're going to be solving for the zeros. We're going to be using the quadratic. We are not going to be solving for vertex. So that's why this is a bonus, only vertex question in word problems. But it was in this example, and I left it in just because I felt like it does, reinforce all the other components that we were talking about. So let's get back to solving these ones and dealing with just the quadratic. So this is a business model one. Suppose that it costs in dollars this much money to produce stereo systems. So it says, how many systems could we produce for 7,500? So C is the cost, and X is the number of stereos. We could graph this one, but what we're saying is 7,500 equals 3,000 minus 60x plus 3x squared. So if we could solve for x here, that would be the number of stereo systems produced for $7,500. So this is a bit ugly. We need to set it equal to 0. And I'd also much rather it was in descending order. So 0 would equal, I'm going to start with the x squared term, then the x term, and then I'm going to put the whole numbers out the back here. So this gives me my equation that I can now start my quadratic with. So x would equal -b plus or minus b squared, whoops, wrong side of the brackets, because they matter, minus 4AC all over 2A. So with some calculator work and making this make a little more sense, those two are easy to do. All of this under the radical, if I crunch the numbers, it works out to the square root of 57,600. And if I hit that square root button, what I'm going to find is that that's a nice, neat number. It gives me the option of doing the positive option, so 60 plus 240, that's the square root of that big ugly number, divided by 6, or 60 minus 240 divided by 6. We can see that this one's going to give me a negative number over here. Well, I guess I could go buy some stereos, but that's not exactly the business model that I'm going with here. So I'm going to ignore that negative option. And this one would actually solve for 50. And so what this is saying is that for $7,500, this business could produce 50 stereos could be produced. Big ugly numbers, but the process is not much different than the other ones that we've done. So one more here, another ready-made equation. The stopping distance in D in meters of a train that's traveling at whatever speed is approximated by this ready-made equation. What speed is the train traveling if the stopping distance is 4,800? So X is the speed and D is stopping distance. So again, with this one, we know what the D is here. This is 4,800. And this is representing the speed that it would be going if it was going to stop at that. So we need to put this into quadratic form. I'm going to subtract 4,800 from both sides to set it equal to 0. So 0 equals x squared plus 20x minus 4,800. You put that equals 0 over on the other side. It doesn't really matter. But this sets me up so that now I have the raw material to sub into my quadratic equation. So x would equal negative b plus or minus the square root of b squared minus 4ac. I never make my radical sign long enough. All over 2a. So I can do some calculator work on this. X equals negative 20 plus or minus the square root of 19,600. I'm not doing my calculator work this quickly. I did these in advance. If I hit the square root, that does work out to a nice even number. I really dislike the ones that I have to round. They seem extra cumbersome to manage. So that would be the positive option, and I also have the negative option. So this gives me two numbers, x equals 60 or x equals a negative 80. And again, we can't go back in time, so that makes me reject that one. And so the train is traveling at 60 meters per second. If you convert that to kilometers an hour, it's about 216 kilometers per hour. I did some sleuthing when I wrote this question to make sure that it actually made sense. And so that's a very fast train, maybe like a European train going that fast. So those are some examples of the ready-made equations. The next video is going to do the geometry equations.